Hello everybody, this is Unit 3, Video 4. This is Miss Moran, and we're going to be working on graphing quadratic equations again. We're going to start with a review of graphing in vertex form. This was our first video from the unit, and we got to practice a little bit in class, and maybe you got to notice the pattern that's created in your table. But most importantly, we had talked about all of the transformations. We identified the vertex, the axis of symmetry, our domain range, and our max or minimum value based on the function we were given. So let's go ahead and start here. The first thing we did was identify our vertex. And our vertex for the given function is 3, -9. When we created our table of values, we went ahead and wrote the vertex in the center. And we knew that that was where the axis of symmetry went. So our axis of symmetry for this is x equals +3. So let's go ahead and choose other values to fill in our table. I'm going to choose 2 that are larger, and I'm going to choose 2 that are smaller. If you had noticed the pattern forming, you'd be able to very quickly complete this table. I'm going to go ahead and skip through that part because you should be able to either use your calculator, you should know the pattern, or it's just merely substitution to create the rest of this table of values. So I'm going to go ahead and fill it in. Okay, so I'm going to plot those points on our graph, and you can do the same in your notebook. I'm going to put arrows on this because it is a function that continues on to forever, which is infinity. And my domain for this will be all real numbers, which can be written with the notation r, or from -infinity to +infinity in interval notation. My range is really dependent on my minimum value, and my minimum value is y equals -9. So my range goes from -9 to +infinity. All right, let's try another one. This time we're going to discuss standard form. And our standard form, similar to the standard form of a line, which was ax plus by equals c, involves the coefficients a, b, and c. A is very similar to the a that was in our vertex form, where it discusses how fast the graph rises, which is either a stretch or a compression. If there is a negative sign, or we have the opposite of a, so if we have a negative a, then we are looking at a reflection. We have bx, which is the linear term of our quadratic, and then c, and our value c is going to come in very important for us. In just a moment I will share that with you. So what we do need to remember is that a cannot equal 0. If a were 0, then the first term, the quadratic term, would be wiped out and we would have a line. So our vertex. To find the vertex, first we will find the axis of symmetry. We will find the axis of symmetry by taking the opposite of b divided by 2 times a. So we will take the opposite of the value of b divided by 2 times the value of a. This is the axis of symmetry. After finding the axis of symmetry, we will substitute that value in. So your vertex is made up of your vertex is made up of the opposite of b divided by 2 times a, comma, f of -b over 2 times a, where we will substitute back in the value that we found for our axis of symmetry into the function. And that will give us the y value associated with it, creating our vertex. Our y-intercept is much more simple to find. Our y-intercept is 0, c, the c from our equation. So let's use this as our first example. So to find the vertex, I'm going to use the axis of symmetry formula. So I will have x equals the opposite of b over 2 times a. And in this case, my b value is -4, or my b is 4, so I will use -4, divided by 2 times 1, or -2. My axis of symmetry is -2. The first, or the x-coordinate of my vertex is -2. I will substitute that back into the function, so f of -2 equals -2 squared plus 4 times -2 minus 3. 4 minus 8 minus 3 is -7. My vertex is -2, -7. From there, I will be able to create my table of values. -2, -7 goes in the center. I know that that's my vertex, and that's also my axis of symmetry that will pass through that point. And I'll choose 2 values that are larger and 2 values that are smaller, and complete my table. Again, I'm going to skip this portion in explaining how I'm doing it because I am merely substituting these values back into my function, or I'm using the pattern. The pattern is similar to how you may have found it using vertex form. And there they are. My domain is all real numbers. My range will come from identifying my minimum value, which is y equals -7. So I'm going from -7 to positive infinity. And my y-intercept, as said, was the value -3. And that's what also happened to show up in my table of values this time. So 0, -3. And that can be seen on the graph as well. Let's try one more. Okay, for this one, we notice we've got a little bit more going on in our equation. Let's go ahead and start by finding the axis of symmetry, which will help us find our vertex. My axis of symmetry is x equals the opposite of b divided by 2 times the value a. And in this case, that is 3/2, or 1.5. So x equals, we'll write 3/2. And the x-coordinate of my vertex is also 3/2. So I'm going to go ahead and carefully substitute that back in as -2 times 3/2 squared plus 6 times 3/2 plus 5. Be sure that when you are evaluating this, that you're only squaring the 3/2 and that you are not squaring the -2, because we have to follow our order of operations. And we should have come up with 9.5, or 19/2. This could have been written equally as 1.5 comma 9.5. Let's go ahead and create our table of values. Okay, so when choosing values in our table, if you go ahead and use your graphing calculator to find additional values in the table, you'll notice that this point does not show up on your table, but you'll notice that the 2 points surrounding it, because they're equidistant from this point, they actually have the same y value right next to each other. And that would be if we had chosen 2 and 1, because those are exactly the same distance away from 1.5. And then we can go ahead and choose 3 and 0. So if we were to choose to substitute in the rest of these values to find our table, go ahead and do that now. Okay, and here's our table, and we had some really nice values once we were able to move beyond the vertex. Let's go ahead and plot those points. Okay, really nice graph there. So our domain, from -infinity to +infinity, Our range this time involves our maximum value, which is y equals 9.5 or 19 halves. My range therefore goes from negative infinity to 9.5. Okay, and my y-intercept, as you can see from the equation or in my table of values, is 0, 5. All right. Okay, so I'd like you to go ahead now and turn to page 303 and work on numbers 19 to 25 odd, making sure that you find all of the important information from both the equation and as you're graphing it.